Okay, solving exponential equation with the two exponential forms with the same basis. So what I meant by same basis, they do have different bases right now, but 9 can be expressed as a base of 3. So we can rewrite this expression as 3 to the power of x minus 1 equal to 9 is the same as 3 to the second power. So to the power of 2x plus 3. Now this equation have two exponential forms with the same basis. We can simplify the left and right hand side. Power to the power, we multiply those two exponents. So 4x plus 6th power. Now we have equation with two exponential forms with the same basis. So their exponents have to be same each other. Then you solve for x. Minus x minus x. So you got 3x plus 6 minus 6 minus 6, you got minus 7 equal to 3x. X equal to minus 7/3. That will be our final answer. Okay, this one is same style, solving exponential equations with the two exponential forms with the same basis. So they appear to be different bases, but you can make them to have the same basis. So 1/5 is the same as 5 to the minus 1 power to the power of 2x power equal to 1 over 125th. 1/125th is same as 5 to the minus 3rd power to the power of 3/4. Now they have exactly same basis as a 5. Power to the power, you can multiply those exponents each other. Minus 3rd power of 3/4, you multiply those two exponents. Now we have a exponential equation which has the same basis on the left and right hand side. So their exponents have to be equal to each other. Solve for x. So multiply by reciprocal both sides. That will give you positive 9/8. That will be final answer. Okay, next topic is solving exponential equation with one exponential form. So we have a one exponential form, 5 to the x power equal to 11. So there are more than one way to deal with this. One way is you take a log on both sides. So it could be natural log, it could be just common log. That wouldn't make much difference at the end. You take the log on both sides. So right here you could have taken natural log both sides, but I just apply the common log, then you can deal with this power of 5. So you use property of the log, bring it down to the coefficient x log base x common log of 5 equal to log 11. So here point is x used to be in the exponent. Now x is not in the exponent anymore. So that was the whole point of taking log on both sides. All you have to do is solve for x here. So divide by log 5, divide by log 5. So x equal to log 11 over log 5. So if this is a no calculator, you're done. Using base formula, you could have expressed that as log base 5 of 11. So either of them could be good answer. Taking log on both sides would work very nicely, even though they have two different exponential functions. So this is a pretty good way to deal with it. Another way to deal with this one is, since we have only one exponential form, you can just convert that using logarithmic form. So from exponential form to logarithmic form. So the exponential form is on the left, keep the log on the left, base is 5, so keep that as a base, then swap it. So base of 11 equal to x, we get exactly the same answer. Pretty handy, but you can only do that when you have only one exponential form. Exactly same style. Solving exponential equation with one exponential form. Here we have a base as e. It doesn't matter whether you take log both sides, natural log both sides, you will end up with exactly the same answer. But since we have natural log, the process will be a little simpler if you take natural log both sides. So I will take a natural log both sides. Then you can take this to the as a coefficient. 3x plus 2 natural log of e equal to natural log of 9. And natural log of e becomes 1. So the equation becomes 3x plus 2 equal to natural log of 9. Solving for x, subtract 2 both sides. 3x equal to natural log of 9 minus 2. Dividing by 3, x equal to natural log of 9 minus 2 all over 3. Without calculator, this would be final answer. Again, since we have only one exponential form, you could have solved this question by just converting this exponential form to logarithmic form. So base is e, we keep that as a base as e in logarithmic form. So log with base e is natural log, and you swap best of those expressions. So natural log of 9 equal to 3x plus 2. We're solving for x, minus 2 both sides. Natural log of 9 minus 2 equal to 3x. Divide by 3, divide by 3. Natural log of 9 minus 2 all over 3 equal to x. You don't have to solve both ways. Just stick to one method you like. The reason I'm showing you this method, it will work even though there are more than one exponential. This one is handy, less work, but it will only work if you have one exponential form. Okay, solving exponential equation with the two exponential forms with different bases. So as you can see, we have one exponential form, another exponential form, base is 3, base is 5. So it's a little bit different than what I just explained. So we can still take a log on both sides, whether it's a common log or natural log, you will end up with exactly the same answer. So let me just take a common log. Log 5 to the power minus 3x minus 1. So you should know the reason we are taking log both sides, because x is on the exponent. X, the variable we are solving for, is an exponent. You want that to be outside of the exponent. So by taking log here, this exponent you can bring it to the front as a coefficient. So parenthesis 2x minus 1 times log 3 equal to parenthesis minus 3x minus 1 log 5. Again, why are we doing this? Now x is on the ground. X is not on the exponent anymore. So all you have to do is just solve for x. So as you can see, we have x on the left hand side, x on the right hand side. So you have to distribute everything. So distribute 3x, log 3, log 3. So it will become 2x log 3 minus 1 log 3 equal to distribute log 5, distribute log 5 minus 3x log 5 minus 1 log 5. So multiplying by 1 doesn't do much. So multiplying by 1 doesn't do much. So I'm not gonna write multiplying by 1 from next step. Here we have x, no x. We have x, we have no x. When you solve for x and first power, you want the terms with x in one side, terms without x on the other side, relatively speaking from equal sign. So I will make a call. I want all the terms with x on the left hand side. He's on the left hand side already. This term has x, so I want him to be on the left. So I'm gonna add 3x plus 5 both sides. This term doesn't have x, so I want him to be on the right. So I'm gonna add log 3 both sides. I'm gonna leave minus log 5 on the right. So what did I do? Terms with x on the left hand side, terms without x on the right hand side. Factor out x from all the terms with x. So factor x out means take x out, take x out. So leftover will be 2 log 3 plus 3 log 5 equal to log 3 minus log 5. All you have to do is solve for x, meaning divide by this parenthesis expression on both sides. 2 log 3 plus 3 log 5, 2 log 3 plus 3 log 5. So x equal log 3 minus log 5 all over 2 log 3 plus 3 log 5 will be your answer. If you need to get equivalent decimal value, you can type this expression into calculator. When you do it, make sure you parenthesize expression on numerator, parenthesize expression on denominator, and type this expression, you get equivalent decimal value. Okay, so this one is a solving exponential equation with the two exponential forms with the same basis, but this one has a constant. So as you can see, exponential form, another exponential form, but we have a constant. So we move everything to the one side. So I'm gonna move everything to the left hand side. So it will become 2 to the power of 2x minus 2 times e to the x power minus 3 equal to 0. So if you look at this expression, e to the 2x power is equal to e to the x power parenthesis second power minus 2 times e to the x power minus 2 equal to 0. So this is a quadratic expression with a factoring. So 1 times 1 makes 1. 1 times minus 3 makes minus 3. You multiply 1 times minus 3 to make minus 3. 1 times 1 makes 1. When you add them, makes minus 2, and then number is matching the minus 2 in the middle. Minus 2 is matching, meaning we found factoring form. So the way you write the factor the form is you put the 2 to the x power here, 2 to the x power here, because 2 to the x power times 2 to the x power makes 2 to the x power to the second power. Put the parenthesis, 1 means positive 1. So here's a factor of the form. 2 to the x power plus 1, parenthesis, 2 to the x power minus 3, parenthesis, equal to 0. So you just continue. 2 to the x power plus 1 is equal to 0, or 2 to the x power minus 3 equal to 0. You're solving for x for each equation. So 2 to the x power equal to minus 1, and right here is the part you should recognize. E to the x power will never become minus 1. So there's nothing you can do. Right here is dead end. No solution on this equation. You keep solving with the other equation, so plus 3 both sides, so e to the x power equal to 3, and you can take a log on both sides. I'd rather just convert that to logarithmic form, so natural log of 3 equal to x. That will be your answer. Since you don't have any solution here, you don't have to mention that.